Oh, I shouldn't do that. We should do not 8 or 9. I'm sorry there. I forgot everybody's name of a break. Leo, we'll come back and get to 10, but 8 and 9 are 3-term adding and subtracting problems, which I think is what Walter's asking for, right? Okay. Let's do 9. So the first thing that I'm going to do is I'm going to start by factoring really everything I can, but in the case of 9, that's really just the denominators. So x squared minus 9 is a difference of 2 squares. X squared plus 2x minus 3, two things that multiply to give me negative 3 and add to give me 2 are positive 3 and negative 1. And then the last one, x squared minus 2x minus 3, multiplies to give me negative 3, adds to give me negative 2, is just negative 3 and positive 1. So my least common denominator here, well, I have an x plus 3, I have one of those, an x minus 3, I have an x minus 1, and I have an x plus 1. Is that okay so far, Walter? So if I look at the first fraction, I'm missing the x minus 1 and the x plus 1, right? So I'm going to multiply those to the top and bottom of that first one. If I look at the second fraction, I'm missing the x minus 3 and the x plus 1. So again, multiplying to the top and bottom. And if I look at the last fraction, I'm missing the x plus 3 and the x minus 1. Are you okay with how I've gotten to here? Still doing okay? All right, so what I need to do next is I need to multiply out the numerators. The denominator doesn't ever really need to get multiplied out, so I'm just going to leave that in factored form. But the numerators I need to multiply out because I need to combine the like terms where possible. So x plus 1 times x minus 1 is just x squared minus 1. And then I still have the 2 up there. And then x minus 3 times x plus 1 is x squared minus 3x plus 2. And when I distribute the negative x through that and get negative x squared, x cubed, plus 3x squared minus 2x. And then here, x plus 3 times x minus 1 is x squared plus 2x minus 3. Oh my goodness, I goofed that up. That should be minus 2x minus 3 there. That should be a plus 2x, and that should be plus 3x. My apologies. And then I'll distribute the same thing here. So that's going to give me plus 2x cubed plus 4x squared minus 6x. And then the denominator there is still the same thing. Still doing okay, Walter?
Yeah.
Okay. So now I'm going to hunt for like terms here. So I have negative x cubed and positive 2x cubed, so that's going to make just a positive 1x cubed. I have 2x squared, another 2x squared, and a 4x squared. That gives me 8x squared. And then I have a 3x and a negative 6x. That's going to give me a negative 3x. And then I just have that negative 2 left over. And I take a quick glance at that numerator there. It's got 4 terms, so if it's factorable, I would try to use grouping on it. But it should be pretty easy to look at that and tell it's not going to be factorable by grouping, because the first 2 terms, the x cubed and the 8x squared, the greatest common factor would just be x squared, leaving you with x plus 8. And the second 2 terms, the negative 3x minus 2, the greatest common factor is negative 1, leaving you with 3x plus 2. And that's not the same as x plus 8, so you can't do a factor by grouping on that, so this is done. It's pretty rare that you're able to factor one of these things at the end to reduce it, but you need to check, right? So that, I think, is your best answer there, presuming I didn't make any arithmetic errors along the way. And that's a bad one, right? That's about as complicated as I could ever expect it to get, and probably more complicated than I would expect you to be able to do on a test or something. As it just got kind of ugly there, right? A lot of multiplying out polynomials that was rather time consuming. That one was pretty rough. I think was probably the worst one on here, right? Those of you that did this. Okay. Leo, you also wanted to see 10, right?
Yeah.
Okay. So I'm going to just change colors and do one of these. So I'm going to start the same way by factoring things. Now, to factor the 2x squared minus x minus 6 and the 3x squared minus 4x minus 4, I have to do that long factoring. So I need to start by finding the 2 things that multiply to give me negative 12 and add to give me negative 1. So that would be negative 4 and positive 3. And so I can take that and rewrite it as 2 groups. From the first group, I can take out a 2x. And the second group, I can take out a 3. Oh, there's a minus 6. That makes more sense. So that factored form is going to be x minus 2 times 2x plus 3. Leo, you remember doing that?
Yeah.
Okay. Can I skip the work to write down for the second one? Okay. Let's see. We got to have 3x minus 4, and then x plus no, it's got to be minus 2 and plus 2. Is that right? Let's look real quick. Oh, plus 2 and minus 2. That's going to be it. Double check that real quick. So that's negative 6. That's positive 2. Yeah. Okay. So there we go. Okay. So again, our least common denominator. Well, we have an x minus 2 that occurs once in each of them. a 2x plus 3 that occurs once, and a 3x plus 2 that occurs once. So that's going to be my least common denominator, is just those three multiplied together. The first fraction is missing a, oh, well, let's be smart about this, right? We could make this problem a little bit easier right at this step by noticing something. So notice that each denominator contains an x minus 2, right? Notice that, everyone? Notice that we're multiplying by the fraction x minus 2 over x plus 1. So when we distribute that through, I can just cancel the x minus 2's here and save myself a little bit of grief. If you didn't do that at this step, that's okay. You'll get it later on. But it just makes the problem a little bit smaller right away, which is nice, right? Leo, are you okay with kind of what I did there?
Yeah.
Okay. Go ahead.
Yeah. Just a little confused about canceling them out. You could just cancel both of them on the bottom. We only have one on top.
Well, it's because this is distributing to each one of these, right? Because it's a multiplication problem inside of the parentheses. So you really have that fraction multiplied to each one of them.
Yeah.
So it cancels, it can cancel each of them, right? Does that make more sense?
Yeah.
Okay. So again, I was a little bit lazy with kind of explaining that, but I'm glad you followed up and made sure that we understood why we're able to do that. Stefan? Absolutely. Okay. Is missing the 3x plus 2. So if I'm all have that. And the second fraction is missing the 2x plus 3. And if I distribute that 3 through, oops, it's going to give me 9x plus 6. And if I distribute the negative 2 through, it's going to give me negative 4x plus or minus 12. And then if I combine my like terms, that's going to be 5x. And then that's my final answer. Is that okay, Leo? Did I lose you anywhere? Your body language isn't great. That's why I'm asking.
I guess I'm okay. I mean, I'm just confused on there's just like 3, then parentheses 3x plus 2 minus whatever. Where do you get, like, why do you put in the 3x plus 2?
So when I make my common denominator, this is missing the 3x plus 2. So I multiplied it top and bottom of that fraction.
Okay.
Is that, you see it now?
Yeah.
Okay. So again, like, I'm trying to show some work as I go. If the work doesn't make sense to you, like where things are coming from, stop and ask, right? Like, the process isn't an unfamiliar one that we're doing, but if I'm not kind of displaying my work in a way that's understandable for you, like, that's a problem, and you should stop and ask, and I'm happy to like re-explain like where things are coming from, or occasionally it's because I make a mistake, and those are always good things to check on, right? Like, I'm counting on you guys to be paying attention and catching some of those things as I make them, because I'm not perfect, and that happens. And that shows me that you're kind of paying attention and keeping tabs on things, which is also good, that you're following along and actively kind of participating. But then there's times where I do too much in one step, and it's, unclear to you what it is exactly that I did. And that's important, again, that you ask about that, and we can follow up. And I'm happy to, take another couple of minutes and explain more about what's going on, or like, okay, like, here's what I did to go from this step to that step, and like, why is this thing coming in here, or how are we able to cancel both of those things? And we went through and explained them, and it hopefully made a little bit more sense after we did that. And you're like, oh, okay, I kind of see it now. And so that's, yeah. So again, don't be afraid to ask about stuff. If I'm bulldozing through something and it doesn't seem clear, like, it's important that it should be clear, or at least as clear as I can make it, right? Do we feel a bit better on this one now after doing some examples? These were two of the harder problems, I think, on the sheet. I think the first half of this thing was considerably easier, right? Keeping track of things, I think 9 was the worst problem on here, or the one where you had to keep track of the most. And the rest of these weren't nearly as bad. But I'm happy to do another if anybody wants me to do one more before we get going on the next set of stuff. Kalila? Okay, on homework 1? Okay, sure. Why are we turning into a black screen on me? Uh-oh. Okay, homework 1, number 13. So the first thing I want to do is turn this into a multiplication problem by flipping the fraction on the right. Now, I'm not going to do that as its own separate step because it's just a lot of extra writing. I'm going to factor and flip at the same time. I just want to make sure that I'm telling you right now that I'm doing both of those steps at the same time and kind of one rewriting so I don't have to rewrite it twice. Is that okay? All right, so let's get to factoring here. Multiplies to give me 5 and adds to give me -6 is -5 and -1. Multiplies to give me 6 and adds to give me -7 is -6 and -1. And then multiplies to give me -12 and adds to give me -4 is -6 and +2. And then multiplies to give me -10 and adds to give me -3 is -5 and +2. Okay, so notice I did the flip in the same step as the factoring, right? So now I can reduce. So I can reduce things straight up and down, so like things inside of the same fraction. And then I can reduce things in the top and bottom. So that canceled everything out. Remember when we cross them out, they begin. So the numerator is really 1 times 1 times 1 times 1, and the denominator is 1 times 1 times 1 times 1, which is just really 1 over 1 or just 1. And that's your answer. Is that okay? Cool. Last call before we move on to the new stuff for today. Okay, if when you're looking over things, there's something you want to see again from any of these two assignments, I'm happy to deal with it later. Yeah?
Well, I'm confused about how -6 and -5 cancel out.
So this -6 canceled with this -6, and this -5 canceled with that -5. Because it's not an addition problem or subtraction problem. It just any top and bottom can cancel with multiplication.
Yeah, okay. Well, it's been long.
Yep. Again, that's why I was, like why I'm spending some time here now redoing this stuff, because again, it's been a minute, right? Everything kind of fades a little bit and it drifts on us, and that's okay. If you look in your content library there, you'll notice there's a homework 1 and 2 review where I just have a couple of problems from homework 1 and 2 that I'm going to ask you guys to do tonight also to just help refresh our memories on things. I don't think it'll, the lecture today is not going to take by any means the entire hour. But, those skills that we developed last time are still important. So let's move on here. So we're going to talk about solving rational equations. So these are going to be solved for x problems. And what I'm going to do is we're going to talk about like linear problems or linear equations involving fractions, something that we've done already in our Algebra 1 or earlier course, and look at some of the techniques we might have used on those kinds of problems and then apply them to these rational function situations or rational equation situations. Okay with that idea? So this should be, again, we're going to start with something that should be relatively familiar. And then we'll take those ideas that we remember and kind of extend them. So let's start with equations. So this type of problem is called a proportion. It's where you just have one fraction equal to one other fraction. So this was something that you would have solved last year in your geometry course. Do you remember how you solved the proportion last year in your geometry course? So this is where we cross multiply. So cross multiplication is a solving technique. It's not a multiplication technique. Basically, all it's doing is converting this equation that had fractions into it into an equation with no fraction in it. Right? Still an equation is the result. But now this is something that's easy to deal with. Because we now can just divide both sides by 7, and there's our answer. Is everybody okay with that idea? Does that ring a bell now that we do it? Maybe. Okay. Oops. Let's now look at a same kind of example using a rational function or rational equation. So I'm going to start the same way. We'll do our cross multiplication. And then I'd have to FOIL each one of these out. So I'm going to just kind of do that in my head. I hope nobody objects to that. So far, so good. Now I notice that I have two quadratics equal to each other, but thankfully in this situation, when I subtract x squared from both sides, it just cancels the x squareds out. Really, we don't have a quadratic equation here. We have a linear equation. So now I can just like add 3x to both sides and then subtract 3 from both sides. And then divide both sides by 7 to get my solution. So worth noting there on this step, we ended up with a linear equation in this example. That will not always be the case. You might end up having to solve a quadratic equation in this step. So either by factoring or more often the quadratic formula. Everybody's okay with that idea? Shouldn't be hard to see that on occasion, if like this coefficient was like 2x minus 5, you'd end up with like a 2x squared on one side and a 1x squared on the other, and you're going to be stuck with a quadratic at some point, right? Doesn't take a lot of imagination to see that's possible to happen. It didn't happen in this example because I was trying to keep things simple, but we certainly can have that happen. There's a second note that I want to make. So not every solution to a rational equation is a true solution. We have to make sure that we check for what are called extraneous solutions. So remember, we encountered these already when we talked about solving absolute value equations way back in semester 1, right? So an extraneous solution is just a solution to an equation that doesn't actually satisfy the equation. For rational equations, it's really easy to check that. All we need to do is check to make sure our solution doesn't give us a zero denominator. So all I'm going to do is I'm going to look at this negative 13 over 7, and I'm going to go back and check if I plug that into either denominator, does it give me 0? No, right? Everybody agree with that? Negative 13 over 7 plus 2 is 7. And negative 13 over 7 plus 1 is negative 6/7. Neither one of those is 0. So it's good. That solution is fine. If that solution gives us a 0 denominator, we discard it. So if you had more than one solution, which you can have, you just discard that one and keep the other ones that it doesn't make 0 denominators for. If that's your only solution and you discard it, you're left with no solution. And that can happen. Not very often, but it's possible. What do you guys think? Is this okay? Let's look at another situation. So let's say we have the equation 1/2 x plus 2/3 equals 7/5. Again, this is just a linear equation, right? This is something you conceivably would have done in your Algebra 1 class. Now, there's a couple of different approaches that you can do with a problem like this. First thing we should note is that this is not a proportion, right? Why is it not a proportion? Well, we have two fractions on the left-hand side of the equation and one fraction on the right-hand side. A proportion is one fraction equal to one fraction, not two fractions equal to one fraction, right? So you cannot use cross multiplication to deal with a situation like this as it's currently written. So some ideas on what we can do. So one idea is we could add those two fractions on the left-hand side to make a single fraction, which would mean we'd then have a proportion, so we could solve that like a proportion. You could do that. Our next option is we could make a common denominator on the right-hand side and left-hand side, and then we could set the numerators equal to each other and solve. Third option is to multiply both sides of the equation by the least common denominator. This technique is also sometimes called clearing fractions. This is the one that I think is the easiest one to use and the most versatile. This is the one that I'm going to show you guys and emphasize. Not to say that the other two are incorrect. You can certainly do those things. But I think that when we talk about operations on rational expressions, the hardest one to do is adding and subtracting, right? Multiplication and division is pretty easy in comparison. Do you guys agree with that? So the advantage of clearing fractions is that you never have to add any fractions together. Is everybody okay with that notion? Okay, so let's see what clearing fractions looks like. So in our case, our least common denominator here would just be 2 times 3 times 5, right? Should be easy to look at that one and tell that. Everybody agree with that? 2 times 3 times 5 is our least common denominator. Since the denominators are all primes, it's easy to see that. So I'm going to multiply this side by 2 times 3 times 5, and this side by 2 times 3 times 5. Note that I'm not multiplying the top and bottom of the fraction by that. I'm just multiplying basically the tops by that. Everybody's okay there? So when I distribute this to the first fraction, the 2's would cancel, right? Everybody agree with that? Well, let's write it out, I guess. And then I'll distribute here. I don't want to leave anybody behind, so I'll write all this out. It'll be a little bit more clear to see it if I do it that way. So when I multiply the first fractions together, the 2's cancel out, and I'm just left with 3 times 5 times x, or 15x. When I multiply the second set of fractions together, the 3's cancel, and I'm left with 2 times 5 times 2, or 20. When I multiply the third set of fractions together, the 5's cancel, and I'm left with 7 times 2 times 3, which is 42. No more fractions. I'm left with a really easy problem to deal with now, right? Notice at no point did I actually have to add any fractions together. All I did was basically do some multiplying and some canceling. I just had to find the right thing to multiply both sides with. Is everybody okay with this idea? Let's do one with rational expressions here so that we can get a good picture of kind of what's going on. So just like all of our previous problems, I'm going to start by factoring. So the only pieces I have to worry about in this problem factoring are the denominators. And hopefully it's pretty easy to see that the least common denominator is going to be x minus 2 times x plus 2 times x plus 3. You guys agree with that? So I'm going to take that least common denominator and multiply it to both sides of my equation. And I'm going to write out what I have. And I'm going to leave it kind of color-coded here, so it's easy to see what's going on. Or easier to see what's going on. Now, why are you doing this, you stupid machine? Okay. Is everybody okay with how I've written this out? Now I'm going to do some reducing. So the first pair of fractions multiply to just give me x plus 3 times 1, or just x plus 3. Then I have 2 times x minus 2. Oh my goodness. Hey guys, your teacher is silly. That was an x there. To copy it down. There we go. My apologies. And then my last one, the x plus 3's cancel, the x minus 2 cancel, and I'm left with 3 times x plus 2. Notice no more fractions now, right? That's pretty rad. Now all I'm going to do is multiply the stuff out. X squared plus 2x minus 4 equals 3x plus 6. So if I move everything on over to 1, x squared plus 2x minus 10 equals 0. This is quadratic, and it's not factorable, right? There's not two numbers that multiply to give me negative 10 and add to give me positive 2. So what do I do in that case? I just use the quadratic formula. So 4 plus 40 is 44. And 44 is really 4 times 11, right? So the square root of 44 is the square root of 4 times the square root of 11. And that can reduce down to just 1 plus or minus the square root of 11. But this one would have been okay for me too. And again, we should check that, but clearly that's not going to give us a zero denominator back in our original problem, because the things that would have given us zero denominators are all integers because everything was factored, right? So we don't have to worry too much about that. What do you guys think? These are basically the two kinds of problems that you'll see in the assignments. Do you want to do more, or do you want to get a chance to dig into stuff and try stuff on your own, so if you run into questions, you can just ask questions immediately? Do that. Okay. So the assignment here for next time, I have, 6 problems here from worksheets 1 and 2. So multiplication, division, addition, subtraction problems. And then I have 10 problems from this homework 3 as 2 separate assignments. But we're done like a half an hour early with lecture, so I'm giving you like 2 sets of problems here to do. One, it's only 16 problems, which again, you can say only is not the adverb I would use to that, or whatever that article of speech is. I'm not sure. Is that an adverb? Grammarians amongst the room? I don't know. Anyways, it's something. But so yeah. But we're done a half an hour early, so you have a chance to get a big jump on this. And I would start with whatever feels the most challenging to you right now, right? If you're like, boy, I definitely need to go back and review the stuff from before, start with that stuff. If you're like, I kind of remember how to do that, I think I'll be okay there, but this new stuff seemed a little hard to me, start with the new stuff, right? You don't need to start with the first problem on the first sheet listed. Like, start wherever you think is going to be the hardest. So if you run into questions, you can get some of that stuff done while you're here and you have access to your teacher who can give you an immediate answer and give you some good feedback right away, versus trying to stumble around like a blind man at home. You know what I mean? Or blind person. I mean, you wouldn't go home and, like, when you didn't understand something, somehow change to a blind gender. Not that blind people are inherently going to be clumsy, but you guys get the idea. Maybe I should say stumble around like you're in a dark room, right? That's maybe a more fair adjective.
Can you do something on the